In this video, we're going to do a breakdown of the build process to create these types of trainers. This one just has a few different example screens. There's not a lot of connection to the I/O yet, but you can see different examples of momentary contacts, start latch, stop unlatch. There's a basic filter example. Then there's some temperature sensors that when the one-wire sensors are enabled, these will read the temperature. And below we have different modules that can be swapped out and used for different purposes. So the one that's being shown here is a Beckhoff EK1100 that's controlling a motor. It has its own power supply because it has to power this 24 volt power supply. And then the Raspberry Pi itself, PLC, has a 5 volt DC power supply that gets powered with a USB-C cable. Before I get into the design of the PLC HMI combo build, I'm going to talk about the different components that make up this build. So first I'll talk about the tools required, and you're going to need a good pair of crimpers. These are about $30 off of Amazon. Next, you're going to want a multi-screwdriver. So this is just a Wera stubby, has different bits inside of it. Then you're going to want a good pair of strippers. And then for materials, you're going to want a set of crimpers that are capable of attaching to 2.8 millimeter plugs. So these are just also off of Amazon. Then you're going to want a good pair of wires, preferably two different colors, so that you can distinguish between hot and neutral or hot and return. And so I just use blue and yellow for that. And now we'll talk about the different components that make up the panel. So everything on the outside of the panel is a surface mount connector, meaning that it connects to the PLC and it allows you to connect to external devices. So the first one I have is going to be this USB-C connector that's meant to be the power for the PLC. And so this is just a USB-C pass-through, and I'll show you how that gets attached to the panel. Next, we have a USB-A pass-through. So the purpose of this is for either external devices using like USB to serial converters, or it can also be used for CODESYS licensing. So when you're using this Raspberry Pi, it runs in increments of 2 hours for free. However, if you want to run it beyond that, you can purchase a license from CODESYS, and that will allow you to run the PLC indefinitely. So this is a USB-A pass-through. It'll also mount on the outside of the panel. We'll go through that. Next, we have a Cat5 surface mount connector, another pass-through. This will allow you to connect Ethernet directly to the Raspberry Pi. You can use that for internet, or you can also use it for external I/O like Ethernet IP, Modbus TCP, EtherCAT, MQTT, and various other protocols. This is what we're using as our PLC. So this is a Raspberry Pi that's been converted, and I've installed the just the standard Raspberry Pi runtime, and we'll go through the process of deploying a CODESYS runtime to this Raspberry Pi to convert it into a PLC, which will allow you to use the GPIOs to turn on or off devices. It will also allow you to read the temperature sensor, which is using the one-wire protocol. Next, we have a DSB1820 temperature sensor. So this is a one-wire sensor. These can be daisy-chained. So if you have multiple DS18B20s, they all connect to the same part of the Raspberry Pi board, and you reference the temperature using the serial number of the device. And I'll show the process of connecting and mapping this in a CODESYS project in a later video. But for now, just know it's a one-wire device. It can be added to the device tree in CODESYS, and you communicate it using the serial number. Next, you're going to want a couple of HDMI to micro HDMI cables. Depending on the version of the Raspberry Pi, this one is a Raspberry Pi 4, so it has two micro HDMI connectors. So these just plug directly into the Raspberry Pi board, and one of these is going to go to the touchscreen. The other one is going to go to an HDMI pass-through, which will allow you to connect to an external monitor or a TV or anything like that. Next, we have the push button light combo. So this is a input device as well as an output device. At the top in the gray area, we have a set of micro switches. So these can be connected to the GPIOs on the Raspberry Pi. And when you press the button, it can open or close a set of contacts, and you can monitor that in the PLC. And then at the top, we have contacts for the light. So when this is energized, the light will turn on. That can be mapped to a discrete output using the CODESYS project. Next, we have our HDMI pass-through connector. So this allows you to connect to an external monitor, external TV, really any device that supports HDMI. Has a little seal, and it will also mount to the surface. Then we have our stationary switches. So these also tie into the GPIO. They can be mapped to discrete inputs in your PLC project. These are simple rocker switches. They have both an input for the switch as well as an output for the light. In my trainers, I really only use the input for the switch. The lights, I use the larger arcade style push buttons. So for this, we just use it simply as a switch, and that will connect to GPIO, and we can monitor the status of that in our PLC program. Next, we have a grommet for our DS18B20 sensor. So this will mount to the trainer panel, and then the DS18B20 will sit inside of that. You can see, I can slide it here. And this will be the part that's shown on the outside of the panel with the wiring behind on the inside of the panel. Next, we're going to want just a standard micro USB cable, USB-A to micro USB. This functions as the touch functionality for the touchscreen. So we need this to power up the touch portion of the touchscreen. Next, we have our touchscreen. I use a variety of different touchscreens. I don't really have a favorite, so I often have to modify the measurements when I'm designing the panels. But these are available on Amazon. They're meant to work with Raspberry Pis. They typically have one HDMI cable input, two touch inputs for USB, micro USB. You can generally turn on or off the backlight. That just means turn on or off the screen. And this is 1024 by 600 pixels. So when we create our visualization projects, we will use that as our static resolution. So these can be used and repurposed as HMIs. You'll see when I do a demo of the kit how we're using the CODESYS IDE to create visualizations and then display those on these touch panels so that you can then use that for training. Next, you're going to want a USB-C power supply. I'm just using a standard kind of low wattage laptop power supply. It's plenty enough power for this purpose. This is just a HP laptop USB-C power supply. So we need that. Then we have our case. The one I used for this demo is a Apache 2800. You can buy these from Harbor Freight. They're about $40. It's a small case, portable, makes it nice for the trainer, and you can just open, and you'll see in a later part of the video that we'll have our panel at the top here, and then we'll have some DIN rail and different things at the bottom so that we can add I/O to this box and configure it and make it somewhat universal. On this panel, you can see that I've already installed some rivet nuts. So these are rivet nuts, and then I have some M8 standoffs here. So this is where we'll actually screw our panel into the back of the Apache case. Okay, now we're going to talk about the design of the panel. I'm using an Xtool S1 20-watt laser to cut these panels. So this software is Xtool Studio. One of the most important parts of this trainer kit is making sure that the design is correct. So we're going to turn a few of these on. I want to make sure I have all the scoring edges turned on, and then I'm going to turn on all of the engravings. I'm going to turn on the CODESYS logo. We'll CODESYS brand this one. And then we're going to use the 5-inch screen instead of the 7-inch screen. So I'll go ahead and select the 7-inch screen and turn that off. And then I just want to make sure everything else looks correct. We're going to go ahead and turn off this HMI cutout and the scoring here. Alright, so once the design looks good, we're going to select a material. So I've selected this dark blue for this material. I like the way it looks with the CODESYS logo, so that's why I've selected this color. And it will engrave to sort of a light blue slash white color. And my laser is just below my workstation here. So I'll just pop open the lid, and we're going to align this by putting the cursor in the top left corner of the design, and then we're going to match that to our panel here. And this is a really tight design because my sheet is just under 12 inches wide, and my design is also just under 12 inches wide. So we're going to go ahead and do the framing function to make sure that the design is within the frame. You can see it's right on the right edge, and we're also right on the left edge. So it looks pretty good. I need to tilt it a little bit, and then I'll run it again. I might have tilted it a little too far, so we'll tilt it a little bit back. Then we'll frame again. That looks pretty good. And this design, it's pretty thick acrylic, so I'm actually going to run a few passes here, just due to the thickness of the material. And so on all the parts where we're cutting, we're going to go and do 3 passes, and we're going to do a speed of 1. All right, so that all looks good. So I will go ahead and process. And this one's going to take about 2 hours, so quite a big job here. A little bit longer than I normally do, but we'll run that for 2 hours and check in on it periodically and see how it's doing. Alright, my laser is now in the cutting portion, so you can see it's cutting out the circles for each of the push button lights.